Hello, everyone. Welcome to our presentation. Today, we're diving into the fascinating world of data with a focus on playing with numbers. This is the first slide, so I want to start by setting the stage for what's to come. We'll explore how numbers can reveal insights, tell stories, and even challenge our assumptions. Over the next few slides, we'll look at different techniques, examples, and best practices for working with data effectively. I'm excited to have you all here, so let's get started. Let's take a look at the contents of today's lesson. We will explore several key topics to help us understand numbers better. First up, we have factors and multiples, which are fundamental concepts in understanding how numbers relate to each other. Then, we'll move on to prime and composite numbers, where we'll learn to distinguish between different types of numbers based on their factors. Next, we'll discuss the highest common factor, which helps us find the greatest number that divides two or more numbers evenly. Following that, we'll look at even and odd numbers, a basic but important classification of integers. After that, we'll go over divisibility rules, which are handy tricks to quickly determine if one number can be divided by another without a remainder. Finally, we'll explore the least common multiple, which is the smallest number that is a multiple of two or more numbers. Throughout this presentation, you'll see how all these concepts connect and build a strong foundation for understanding the mathematics of numbers. Let's take a closer look at factors and multiples. Factors are the numbers that divide into a given number exactly, without leaving a remainder. For example, factors of 12 include 1, 2, 3, 4, 6, and 12. Recognizing factors helps us understand the building blocks of numbers and their relationships. On the other hand, multiples are the numbers we get when we multiply a number by an integer. So, multiples of 3 are 3, 6, 9, 12, and so on. Multiples show us the pattern of numbers that are evenly spaced based on a common factor. Understanding factors and multiples is essential because they form the foundation for many concepts in mathematics, like simplifying fractions, finding common denominators, and solving various problems involving divisibility. Throughout this presentation, we'll see how these ideas connect to broader topics and help us solve real-world problems more effectively. So let's talk about factors. A factor is essentially a number that divides another number exactly, without leaving a remainder. For example, if we look at the number 12, its factors are 1, 2, 3, 4, 6, and 12. Each of these numbers can go into 12 evenly. The key idea here is that factors are the numbers that fit perfectly into a larger number. Recognizing factors helps us understand the structure of numbers, which is fundamental in many areas of math, including simplifying fractions and finding common divisors. So, when we talk about factors, think of them as the building blocks that multiply together to make the original number. This concept ties into our overall theme of understanding number relationships and divisibility. All right, let's talk about multiples today. So, a multiple of a number is basically what you get when you multiply that number by any whole number. For example, if we look at the number 2, its multiples are all the numbers you can get by multiplying 2 by 1, 2 by 2, 2 by 3, and so on. Let's see it in action. When we do 2 times 1, we get 2. That's our first multiple of 2. Then, if we do 2 times 2, we get 4. That's the second multiple. And continuing, 2 times 3 gives us 6. This idea of multiples is really important because it helps us understand patterns in numbers and is fundamental when we're working with factors, divisibility, and even more advanced topics later on. Remember, the key point here is that multiples are simply the results of multiplying a number by whole numbers, and they help us see the relationships between numbers in a clear way. Now, let's take a closer look at even and odd numbers. These are fundamental concepts in mathematics that help us understand how numbers work. Even numbers are those that can be divided by 2 without leaving a remainder. For example, 2, 4, 6, and 8 are all even numbers. On the other hand, odd numbers are those that, when divided by 2, leave a remainder of 1. Think of numbers like 1, 3, 5, and 7. Recognizing whether a number is even or odd is a basic skill, but it also connects to many other mathematical ideas, like patterns and divisibility. Throughout this presentation, Understanding these concepts will help us see the bigger picture of number properties and relationships. Let's take a closer look at even numbers. An even number is any number that can be divided by 2 without leaving a remainder. For example, numbers like 2, 4, 6, and 8 are all even because when you divide them by 2, you get a whole number. This is a key concept because it helps us quickly identify certain numbers in math problems. Now, moving on to odd numbers. These are numbers that are not divisible by 2, meaning when you divide them by 2, you end up with a remainder. Examples include 1, 3, 5, and 7. Recognizing whether a number is even or odd is fundamental for understanding many mathematical patterns and operations. Connecting this to our overall theme, understanding even and odd numbers helps us grasp the structure of numbers and their relationships, which is essential for more advanced topics later on. Let's take a closer look at prime and composite numbers. Prime numbers are numbers greater than 1 that have no divisors other than 1 in themselves. They are the building blocks of all numbers, much like the basic units in a larger structure. For example, numbers like 2, 3, 5, and 7 are prime because they can only be divided evenly by 1 in themselves. On the other hand, composite numbers are numbers that have more than 2 divisors. These are numbers that can be divided evenly by numbers other than 1 in themselves. For instance, 4 can be divided by 2, and 6 can be divided by 2 and 3. Understanding the difference between prime and composite numbers is fundamental because it helps us grasp how numbers are constructed and related. This concept ties into the overall idea of number properties and their importance in mathematics, especially when working with factors, multiples, and number patterns. Recognizing whether a number is prime or composite can also make problem-solving more efficient. All right, let's talk about prime numbers. A prime number is a special kind of number that has only 2 factors, 1 in itself. This means it can't be divided evenly by any other numbers. For example, take the number 2. Its only factors are 1 and 2, so it's a prime number. Similarly, 3 is only divisible by 1 and 3, making it prime as well. The number 5 follows the same pattern, being divisible only by 1 and 5. Understanding prime numbers is fundamental because they are the building blocks of all numbers. They help us understand the structure of numbers and are essential in many areas of mathematics, especially in number theory. Throughout this presentation, you'll see how prime numbers connect to larger concepts like factors, multiples, and even encryption methods. So remember, a prime number is simply a number with no divisors other than 1 in itself. It's a fundamental concept that underpins much of math. Let's talk about composite numbers. A composite number is a number that has more than 2 factors. In other words, it can be divided evenly by numbers other than just 1 in itself. For example, take the number 4. Its factors are 1, 2, and 4. Since it has more than 2 factors, 4 is a composite number. We can express 4 as 1 times 2 times 2, which highlights its factors more clearly. Another example is 6, which has factors 1, 2, 3, and 6. We can represent 6 as 1 times 2 times 3. Recognizing composite numbers is important because they are made up of prime factors, and understanding this helps us see the building blocks of all numbers. This concept ties into our overall goal of understanding the structure of numbers and their relationships. Now let's talk about coprime numbers. 2 numbers are called coprime if they only share 1 as a common factor. Essentially, this means they have no other common divisors besides 1. For example, consider 15 and 16. When we look at their factors, 15 is 1 times 3 times 5, while 16 is 1 times 2 times 2 times 2 times 2. Since the only common factor they share is 1, these 2 numbers are coprime. Recognizing coprime numbers is important because it helps us understand the relationships between numbers, especially in topics like fractions, ratios, and number theory. It ties back to our overall theme of understanding how numbers work together and differ from each other. All right, let's talk about common factors. When we find the factors of 2 or more numbers, we're essentially looking at all the numbers that can divide those numbers evenly without leaving a remainder. Now, the key part is identifying which of those factors are shared between the numbers. That's what we call common factors. For example, if we take the numbers 6 and 8, we list out their factors. For 6, the factors are 1, 2, 3, and 6. For 8, the factors are 1, 2, 4, and 8. Notice how the common factors are the numbers that appear in both lists, which in this case are 1 and 2. Recognizing these common factors helps us see the relationship between the numbers and is especially useful when we're working toward finding the greatest common factor or simplifying fractions. So in summary, common factors are just the factors that two or more numbers share, and identifying them is a key step in many mathematical concepts. Let's talk about common multiples. These are the multiples that two or more numbers share. When we say common multiples, we mean the numbers that appear in the lists of multiples for each of those numbers. For example, if we look at 2 and 3, their multiples are different sequences. For 2, the multiples are 2, 4, 6, 8, 10, 12, and so on. For 3, the multiples are 3, 6, 9, 12, and so forth. Notice that 6 and 12 show up in both lists. These are what we call common multiples because they are multiples of both 2 and 3. Understanding common multiples helps us find shared factors and solve problems involving multiple numbers working together. It's a key concept in understanding how numbers relate to each other, which ties into the broader theme of discovering patterns and relationships in math. Let's take a closer look at divisibility rules. These rules are handy shortcuts that help us determine if one number is divisible by another without actually doing the full division. For example, there are specific rules for numbers like 2, 3, 5, and so on, which make mental math much easier. Understanding these rules is key because they save us time and help us quickly identify factors, prime numbers, and even simplify complex calculations. As we connect this to the bigger picture, mastering divisibility rules enhances our number sense and problem-solving skills, which are essential in many areas of mathematics. So, keep these rules in mind. They're powerful tools in your mathematical toolkit that make working with numbers more efficient and intuitive. Let's talk about divisibility by 2. The key idea here is that if the unit, or the last, digit of a number is even, then the entire number is divisible by 2. So in simpler terms, look at the last digit. If it's 0, 2, 4, 6, or 8, that number can be divided evenly by 2. For example, take the numbers 2, 4, 258, or 2480. All of these end with an even digit, and as a result, they are divisible by 2. This rule is really handy because it lets us quickly identify whether a number is divisible by 2 just by checking its last digit, without the need for long division. This concept ties into our overall theme of understanding basic divisibility rules, which are foundational for simplifying and solving many math problems efficiently. Now, let's talk about divisibility by 3. A really handy trick here is to look at the sum of all the digits in a number. If that sum is divisible by 3, then the entire number is divisible by 3 too. For example, take the number 4782. If we add up its digits, 4 plus 7 plus 8 plus 2, we get 21. Since 21 is divisible by 3, we can conclude that 4782 is divisible by 3 as well. This method makes checking divisibility quick and simple, and it ties into the overall theme of understanding number patterns and properties. Now, let's talk about divisibility by 4. The key idea here is that if the last two digits of a number are divisible by 4, then the entire number is divisible by 4. This is a really useful shortcut because it saves us from having to divide the whole number. For example, take the number 248. Look at the last two digits, which are 48. Since 48 divided by 4 equals 12, with no remainder, we know 48 is divisible by 4. Therefore, the entire number, 248, is divisible by 4 as well. And just to clarify, the example I gave was 248, but if we see a number like 24,824, we only need to check the last two digits, 24. Because 24 divided by 4 equals 6, with no remainder, so 24,824 is divisible by 4 too. This rule is particularly handy when working with large numbers, making divisibility checks faster and more straightforward. It ties into the overall theme of understanding patterns in numbers to simplify mathematical operations. Now, let's talk about divisibility by 5. The key idea here is that if the last digit of a number is either 0 or 5, then that number is divisible by 5. For example, take the numbers 24,680 and 24,685. Notice how in both cases, the last digit is either 0 or 5, which means these numbers are divisible by 5. This rule is really useful because it lets us quickly identify whether a number can be divided evenly by 5 without having to do the actual division. Remember, this simple check, the last digit, can save us a lot of time when working with larger numbers or checking multiple numbers. It's a fundamental concept that fits into our overall understanding of divisibility rules, making math a bit easier and more intuitive. Let's talk about divisibility by 6. The key idea here is that if a number is divisible by both 2 and 3, then it must also be divisible by 6. This is an important concept because it simplifies checking for divisibility by 6. Rather than testing the number directly, we can just verify these two conditions. For example, let's look at the number 24,822. We can check if it's divisible by 2 by looking at the last digit, which is 2, so yes, it's even. Then, to check divisibility by 3, we add up the digits. 2 plus 4 plus 8 plus 2 plus 2, which equals 18. Since 18 is divisible by 3, the number 24,822 is divisible by 3 as well. Because it satisfies both conditions, divisible by 2 and 3, we can confidently say that 24,822 is divisible by 6. This rule ties back into our overall theme of understanding divisibility rules and how they help us quickly determine factors without needing to perform full division. Let's talk about divisibility by 7 today. The key idea here is that if you have a number and you want to check if it's divisible by 7, there's a handy trick you can use. Here's how it works. First, you take the last digit of the number and set it aside. Then, you look at the remaining part of the number. The next step is to multiply that last digit you set aside by 2. Once you have that, you subtract this result from the remaining part of the number. If this new number is divisible by 7, then the original number is also divisible by 7. Let me give you an example to make this clearer. Suppose we start with the number 12,334. We separate the last digit, which is 4, from the rest, so we have 12,333 and 4. Next, we multiply 4 by 2, which gives us 8. Now, we subtract 8 from 12,333, resulting in 12,325. But wait, in this example, I actually made a small mistake. Let's correct that. The subtraction should be 12,333 minus 8, which equals 12,325. Sorry about that. Now, the key point is to check whether 12,325 is divisible by 7. If it is, then 12,334 is divisible by 7 as well. In this case, 12,325 divided by 7 gives us 175, confirming that it is divisible. This method is a quick and efficient way to test divisibility by 7 without doing long division every time. It connects to the larger idea of using pattern recognition and shortcuts in math to make calculations simpler and more intuitive. Now, let's talk about divisibility by 8. The key idea here is that if the last 3 digits of a number are divisible by 8, then the entire number is divisible by 8 as well. For example, take the number 123,216. To check if it's divisible by 8, we look at the last 3 digits, which are 216. When we divide 216 by 8, we get 27 with no remainder. Since 216 is divisible by 8, this means that the whole number, 123,216, is divisible by 8 too. This rule is really useful because it simplifies the process. Rather than dividing the entire number, we only need to check the last 3 digits. It connects to our overall theme of understanding simple divisibility rules that help us quickly determine factors of larger numbers. Let's talk about divisibility by 9. The key point here is that if the sum of a number's digits is divisible by 9, then the entire number is divisible by 9 as well. For example, take the number 2484. If we add up its digits, 2 plus 4 plus 8 plus 4, that gives us 18. Since 18 is divisible by 9, we can conclude that 2484 is also divisible by 9. This rule is very handy because it allows us to quickly check if a number is divisible by 9 without actually performing the division. It connects to our overall theme of understanding divisibility rules and making math easier and more efficient. Now let's talk about divisibility by 10. The key idea here is quite simple. If the last digit of a number is 0, then that number is divisible by 10. For example, take the numbers 12,490 and 24,870. Both of these end in 0, so they are divisible by 10. This rule is very straightforward and useful because it helps us quickly determine whether a number can be divided evenly by 10 without having to do the actual division. Remember, the essential point is checking the last digit. If it's 0, the whole number is divisible by 10. This concept ties into our overall theme of understanding divisibility rules, which make working with numbers much easier and more efficient. Let's take a closer look at divisibility by 11. For example, the numbers 308, 1331, and 61,809 are all divisible by 11. To see if there's a pattern, we can create a simple table and analyze the digits of each number. What we observe is that, in each case, the difference between the sum of the digits in the odd positions and the sum of the digits in the even positions is either 0 or a multiple of 11. This is a key point because it helps us quickly determine whether a number is divisible by 11 without actually performing the division. And as we see here, all these numbers are divisible by 11 based on this pattern, which highlights the importance of recognizing digit patterns in divisibility tests. This technique connects to our overall theme of understanding how patterns in numbers can simplify complex calculations. All right, let's talk about the highest common factor, or HCF for short. This is a really useful concept when you're dealing with numbers and trying to find what they have in common at their highest level. Essentially, the HCF is the largest number that divides two or more numbers exactly, without leaving a remainder. For example, if you look at 12 and 18, their HCF is 6 because 6 is the biggest number that goes into both evenly. Understanding the HCF helps us simplify fractions, solve problems involving divisibility, and find common factors in various situations. It's all about identifying the biggest shared building block between numbers, which ties into the broader theme of understanding relationships between numbers and making calculations easier. Now, let's talk about the highest common factor, or HCF for short. The HCF is the largest number that divides two or more numbers exactly, without leaving a remainder. It's a useful concept because it helps us simplify fractions and find common factors among numbers. When we're working with multiple numbers, identifying their HCF can make calculations much easier and clearer. Remember, the HCF is always less than or equal to the smallest number in the set. Understanding how to find the HCF ties into our broader goal of mastering number relationships and simplification techniques. So, grasping this concept is a key step in developing stronger skills in number theory and problem solving. Let's take a look at the least common number. This concept helps us identify the smallest value that appears in multiple sets or lists. It's particularly useful when we're trying to find common ground or shared elements among different groups. Think of it as the smallest number that shows up across various data points, making it a key concept in problem solving and analysis. By understanding the least common number, we can streamline our approach and focus on the most relevant shared data. This ties into our overall theme of finding connections and simplifying complex information. So, always remember to look for that smallest shared element. It often reveals the most crucial insights. Now, let's talk about the least common number. This concept is all about finding the smallest number that two or more numbers can divide into evenly. It's a key idea in understanding how different numbers relate to each other, especially when working with fractions, ratios, or scheduling. The least common number helps us synchronize things efficiently, like making sure events line up or simplifying calculations. Remember, finding this number involves identifying the smallest multiple shared by all the numbers involved. It's a fundamental tool that connects to the broader theme of finding order and consistency in math and real-world problems. Mastering this concept makes other math operations much easier and more intuitive.